Solving equations level 4. In last level, we're looking at equations with brackets and or a few fractions. So with the tougher questions, the level 4 questions, it's important to clear the fractions first. This just makes it easier for us to solve. And this is done by multiplying every term by the lowest common multiple, or the LCM. And we already know how to solve our equations that we looked at in level 1. These are our two-step equations when we had a fraction and then a constant term. So we did that. So one way to solve this, though, is by taking a look at what our denominator is. So this is a different way on how to solve it than we looked at in the level 1 lesson. But it's still a valid solution, and it'll help us when we get to some of these harder ones. So what we can do is we can multiply every term by the denominator. In this case, it happens to be 4. So I'm multiplying 4 by x over 4, and I'm multiplying 4 by 1, and I'm multiplying by 4 by 3. And the reason why I do that is because this way it gets rid of that fraction in that first step. So 4 divided by 4 is 1, so I'm just left with x. 4 times 1 is 4, and 4 times 3 is 12. And then it becomes something that we know how to solve. So we bring over the 4, so we subtract 4 from both sides, so x is equal to 8. So that's another way that you can solve those two-step equations when you have a value in the denominator of one of your terms. So we're going to show how this works in our other examples here. So again, I'm going to start by showing you lots of steps so that you have those steps to refer to. You are welcome to do the shortcuts that you've picked up along the way. So the first thing I want to do is I want to get rid of this denominator. So right now my denominator is 5. So I'm going to multiply every single term by 5. So I'm going to multiply the left-hand side by 5. And I'm going to multiply my right-hand side by 5. 5 divided by 5 is 1, so those two cancel out. So I'm left with 6x minus 2 is equal to 5 times 2, which is 10. From here, it becomes an equation that I know how to solve. I start by looking at my constant term, do the opposite operation. So I'm adding 2 to both sides. Negative 2 plus 2 is 0, so I just have 6x on the left-hand side, and 10 plus 2 is 12. From here, I'm going to get rid of the coefficient in front of my variable, which is multiplication. So I'm doing division, so I'm going to divide both sides by 6. 6 divided by 6 is 1, so 1x, or just x, and 12 divided by 6 is 2. So that is one way that you could solve these questions. So look at your denominator and multiply every single term on both the left-hand side and the right-hand side by that value in order to get rid of your fractions, and then you can solve it using the strategies that we picked up in the previous level lessons. Let's take a look at this next example. So I have 3y equals 20 plus 10y over 3. So I want to get rid of those fractions. So in order to do that, I need to multiply by, so in this first example, I multiplied both every side by 5. So that's what we did in this first step. Okay, so in this case, I'm going to multiply every single term by my denominator, which happens to be 3. So that's what I'm doing in this question. So this is what it looks like. I'm multiplying by 3y. I'm multiplying 3 by 20, and I'm multiplying 3 by 10y over 3. 3 times 3y is 9y. 3 times 20 is 60, and those 3's cancel each other out in this last term, so I'm just left with 10y. And now it becomes a question that's easier for me to solve. So I'm going to go ahead and move my variables to the left-hand side. Again, you can move them to the right-hand side. It makes no difference. So I'm going to move my 10y to the left-hand side. So I'm going to do the opposite of adding 10y, which is subtracting 10y from both sides. 9y take away 10y is negative 1y. And then I have 60, and 10y take away 10y is 0. And then from here, I want to get rid of the coefficient in front of the variable. So I'm going to divide both sides by negative 1. Negative 1 divided by negative 1 is 1y, or just y. And 60 divided by negative 1 is negative 60. So if you had moved the variables to the left-hand side or the right-hand side, then you wouldn't have had to divide by negative 1. But you would have had to move over the 60 to the left-hand side. So it's really half a dozen of one, 6 of the other. So I've taken some shortcuts in these last few steps. I haven't showed you every single step. So if you have any questions about this, please let me know. Okay, let's go over a couple more examples. So I have m over 3 equals 5 plus m over 4. In this case, I have two different denominators. So this is where I'm looking for that lowest common multiple. So I'm looking for a multiple of 3 and a multiple of 4 that both 3 and 4 will divide into. So remember, a multiple is something that we got to think about our times tables, right? So for 3, it's 3, 6, 9, 12, 15, and so on, right? For 4, it's 4, 8, 12, 16, and so on. So that lowest common multiple happens to be 12 in this case because it's the number that occurs in both of these lists, okay? So this time I'm going to multiply every single term by my 12. So I'm multiplying 12 by m over 3. I'm multiplying 12 by 5, and I'm multiplying 12 by my m over 4. I'm still going to get rid of my fractions, but it's not going to get rid of them completely in terms of the numerator and the denominator, because I need to think about, well, how many times does 3 go into 4 or 12? And that's 4 times. And how many times does 4 go into 12? That's 3 times. So I'm getting rid of the fraction, but I'm not getting rid of the coefficient in front of this term. So I'm left with 4m is equal to 12 times 5, which is 60, and plus 3m. So I've gotten rid of my fractions, but as I said, I didn't get rid of this coefficient term. So now this becomes a question that I know how to solve from my previous lessons. So I'm going to move my variables to one side of the equation. I'm going to go ahead and move them to the left-hand side. So the opposite of adding 3m is subtracting 3m from both sides. 4m take away 3m is 1m, or just m. That's equal to 60. And 3m take away 3m is 0. And when I have a 0, I don't need to write that 0. So I have m is equal to 60, and that's my final answer. And for this last example, again, I have two different denominators. So this is where I have to look for that lowest common multiple. So I'll start with my 3. I have 3, 6, 9, 12, and so on. Then I look at my 2. I have 2, 4, 6, 8, 10, and so on. So that smallest number that appears in both of these lists is 6. So 3 divides evenly into 6, and 2 divides evenly into 6. So I have to multiply every single term by 6. So I have 6 times x plus 3, and I have 6 times x minus 4 over 2, and I have 6 times 7. 3 goes into 6 2 times, and 2 goes into 6 3 times. So I have 2x plus 3 times x minus 4 is equal to 6 times 7, which is 42. So you'll notice in this case, I have a bracket that I need to look after first. So I want to apply the distributive property to everything inside of this bracket. So I have 2x, 3 times x is positive 3x, and 3 times 4, negative 4, is negative 12. So I've gotten rid of my fractions in this first step, and then I apply the distributive property in the second step. Now I want to collect any like terms. So I have 2x terms on the left-hand side. So 2x plus 3x is 5x. So I have 5x minus 12 is equal to 42. So I've just simplified that left-hand side. From here, I want to get rid of my coefficient, or my constant term, sorry. So my constant term that's on the same side as my variable is negative 12. The opposite of adding negative 12 is adding positive 12. So I'm going to add 12 to both sides. So I have 5x, negative 12 plus 12 is 0, and 42 plus 12 is 54. And then from here, I want to get rid of the coefficient in front of the variable. The opposite of multiplying by 5 is dividing by 5. 5 divided by 5 is 1, so I'm left with 1x, or just x. And this is where it's not going to work out nicely, so I'll take a look at my calculator. 54 divided by 5 is 10.8. So again, don't shy away from those decimal numbers. They won't always work out to a nice whole number, so keep that in mind as well. If you have any questions about this lesson, please reach out to me, send me an email, or sign up for a virtual help session, and I will see you in the next lesson.